Hello, Year 11. We are now going to start going over our chemistry paper one. The topic that I'm going to have a look at with you guys is bonding, and this is for combined higher. So, the three main types of bonding, what are they? Okay, if you need to, take a pause on this and add those three types, but I will go on ahead and say what they are. So, that should be your ionic bonding, your covalent bonding, and your metallic bonding. And then the next question would be, how would you be able to identify which one is which? So ionic bonding happens between metals and non-metals. So you need to look at the elements that are pretty much on the opposite side of the periodic table. Covalent bonding happens only in non-metals, okay? So your oxygen with oxygen, hydrogen with hydrogen, just staying within that area of the periodic table, okay? Your right-hand side. And then finally, metallic bonding, as the name suggests, happens in metals. Okay, so when you just see sodium on its own or magnesium on its own, or even alloys, which are mixtures of your metals, understand that that would be metallic bonding. So make sure not to use what you understand for ionic or covalent bonding in metallic bonding, and obviously vice versa. Don't get them muddled up. Now, moving on to ionic bonding. So we spoke about how ionic bonding happens between metal and non-metal. Understand that this is when electrons are transferred. So they move from one to the other. And specifically, it's the metal atoms. So the metal atoms lose their electrons and then they become positively charged. So I always explain it as, think of electrons like the money. So the one that's given the money away, like you're given to charity, you're the good person. So the metal or the atom that gives the electrons away is always positive, and then the one that takes it for itself is negative. So your non-metal atoms gain electrons, and as a result, they become negative. So metals will always have positive charges, and non-metals will have negative charges, and it's those two opposite charges that then attract. Okay. Now, how would you know what ions you'd have? So it depends on the group. So if you're group one, you're going to have a 1 plus charge. If you're group two, you're going to have a 2 plus charge because you have those electrons in the outermost shell. Okay. Whereas if you're in group seven, that means you have 7 electrons in the outer shell. And if that is the case, then in order to get a full outer shell, it's easier for you to gain that last one instead of trying to lose the 7 that you have. And as a result of that, you'd end up with a -1 charge. So that's kind of me going off on a tangent here, but let's go back to this gap fill. Um, so all of them are basically trying to get to the structure, the electronic structure of a group zero, which is called your noble gas. Okay, they're all trying to become like the noble gases and be full on their outer shells. Right, so group number tells you the number of electrons in the outermost shell. So potassium has one electron, is in group one, so it's got one electron in the outermost shell. Magnesium's in group two, so it's going to have 2 electrons in the outermost shell, so they're all going to be the same. The group number, which is your vertical column, tells you the number of electrons in your outermost shell. Then the next part is the ion. The ion just means what charge will it have. So if you're in group one, that means you have 1 electron in your outermost shell. What are you going to do? You want to become full. So your two options are you can lose that one or you can try to gain 7. And it's easier to lose that one. So you lose the one. Remember, losing means you're positively charged, so they get a +1 charge. So you get a potassium plus. If it's a 1 plus, you don't really need to worry about um, showing that one there, but essentially you get that plus charge. So moving on to magnesium, it's in group 2, 2 electrons in the outermost shell, so it's going to lose 2 or try to gain 6. Remember, the outer shell has 8, right? So what it will then do as a result of that is it will just try to lose that 2. So magnesium is going to have a 2 plus charge. And then you work the same way through all of them, okay? So if I was to pick on the nitrogen one, for example, nitrogen is in group 5. That means you have 5 electrons in the outermost shell. And if you've got 5 electrons in the outermost shell, you're either going to lose that 5 or gain 3. And therefore, it's easier to gain 3. Gaining means you're negative, so it's going to be a 3 minus charge. Okay, your job is to understand how to draw those ions. Okay, you need to know the charges of them. Okay, so ionic bonding. Electron transfer during ionic bonding. So you need to know how it works. First step, draw the actual atom. Okay, you look at the atomic number, which is the smaller number on the periodic table, and that tells you the number of electrons. So in this case, your sodium would have 11 electrons. The outer shell will be having 1. So you're going to show that one, make one of them dots, and the other one crosses. It doesn't matter which one you make which, just make sure they're different. And then when the transfer happens, so logically, it kind of makes sense. Sodium will lose that one, and that one will jump over onto your chlorine. So the final result is going to show your chlorine with the 7 electrons it had in the beginning, because it started off as a group 7 element, plus that one electron. And how you know that electron came from a different atom is because it's a dot, whilst the others are all around it are crosses. And then sodium has lost that one, so you show it empty. Make sure you have the square brackets. Okay, I always say to my students, the ionic bonding, the ions, they carry square brackets around them. Okay, almost like these jackets they have on. So always in ionic bonding, show your square bracket and then the charge just at the top corner, outside of the bracket. Okay. Um, yeah, and then that charge is called electrostatic, anything positive and negative. So do give a go on the ones on the sides at the bottom over here where it says number 1, magnesium oxide, and then number 2, calcium chloride. Okay, next. So you should have done that. The answers are over here. Notice how your calcium chloride, so you should have drawn calcium, you'd realize it's group 2, which means it has 2 electrons in the outermost shell. And then chlorine is in group 7, so that means it has 7 electrons in the outermost shell. Now, calcium wants to give 2 away. It says, listen, I've got 2, I need to get rid of that 2. Getting rid of 1 doesn't help me. So it wants to get rid of that 2, but chlorine can only take 1 more. Okay, chlorine's got 7. It needs to get to 8. So another chlorine comes along and takes the other one that the calcium was holding on to. So when you're drawing the final product, you need to make sure you're showing 2 chlorines, each with the cross that came from calcium. And calcium's now happy it's lost that 2 plus charge, and your chloride ions have the negative -1. Okay. Now we're going to look at formulas. Okay, so formulas are essentially how we're going to pair up our elements. Okay, so sodium we've kind of got at the bottom over here, but we should be able to figure them out based on their groups. Sodium is a +1 charge. Fluoride, okay, is a -1. Remember, if you've got the "ide" at the end, that means it's an ion. Okay, so it's gained the electron. Fluorine with the N is when it's still just the atom. Okay, with the 7 electrons in the outer shell. Okay, now when you have Na plus and F minus, so they cancel out and you end up with NaF. Same goes with magnesium. Magnesium's at Mg2 plus, O2 minus, and then you end up like that. Okay, so do put them together. Essentially, you want them to be equal. You want to get an equal charge of them both. So do grab the numbers and swap them down. Okay, so the charges will always fall down. So if we look at the aluminium and sulfide one, aluminium's at Al3 plus. If you draw it right next to sulfur, okay, as you're writing right now, hopefully you've got a piece of pen and paper. So aluminium 3 plus, sulfur 2 minus. Bring your 3 from aluminium down next to sulfur. Bring the 2 that's next to your sulfur down, and then you end up with Al2S3. So they basically kind of swap charges. Okay, we need to know the bonding for it, or rather how they look. The exam question can ask you, why is it that they have high melting and boiling points? Why is it that ionic bondings are like this, that, and the other? You get marks for saying it's a giant structure. You get a mark for saying it has strong electrostatic force. Electrostatic is just a fancy way of saying positive negatives are attracted. Okay, why? From the oppositely charged ions. We always had a plus and we always had a minus. Um, and this is called a lattice. A lattice just means a regular structure. Okay, so as you can see over here in the corner, you're going to see plus minus, plus minus, plus minus. Um, Moving on to covalent bonding. So covalent bonding is when atoms share. Okay, and this time you need to show your overlap. Okay, there's simple covalent, there's giant covalent structures, and then there's your polymers. Okay, so you show your dot and cross diagrams to show the overlap. That is how you show covalent bonding. Please do not forget they share electrons. Only ionic is the one with the square brackets. Okay, so here's some examples. Please feel free to go on ahead and draw them yourself. Okay, a single covalent bond has 2 in the middle, so make sure you have a look at that. Okay, if you need a bit more help on drawing covalent structures, then there are plenty of resources, books on Microsoft Teams, YouTube videos, etc. Okay, just make sure you're looking at GCSE AQA. Okay, so this is going to be a double covalent bond because there's 4 electrons, whereas there's usually only 2 electrons. Okay, so we can kind of go through this. If they ask you about the properties of diamond and graphite, know that they are both made of carbon. They're both giant molecules, but that's pretty much where it ends. Okay, diamond, the carbon makes 4 bonds, whereas in graphite, carbon makes 3. Okay, or rather 3 covalent bonds to other carbons. Okay, and that leaves 1 delocalized electron. Okay. Um, all right. Um, okay. Metallic bonding. So how does metallic bonding look? Metallic bonding happens when you have loads of positive metal ions. Remember, our metals are positive, and they're positive because they lost that outer shell of electrons. When they lose that outer shell of electrons, then that becomes delocalized across the layer. Once it becomes delocalized, that is what allows it to conduct electricity. Okay, so if they ever ask you to draw metallic bonds, I think two of these rows should be fine. About 8 atoms or about 10 minimum should be okay. Make sure you draw your um, negative delocalized electrons. Delocalized meaning they're free to move around in the structure. We're also using the word lattice here because it is a regular structure. Okay. Now we're going to look at metal, or I should say pure metal versus alloy. So a pure metal, as you can see, if we look at these two images, the pure metal has the ions, the metal ions are all the same size. Whereas in the alloy, you have these big white circles and the smaller black ones, okay, to show you the different metals that have been mixed together. Okay. Alloys are harder for that reason because since they have different sizes, that layers cannot slide past each other, and that makes the material much stronger and harder. Okay. Quick look at the states of matter. Remember, this is also there in your physics paper. They're all just as important. We need to know the structure of them, and we need to know how they're arranged. Okay. Um, Changes of state. So solid, liquid, gas, and then sublimation. Okay. So the strong forces happen between your solids, okay? And then that's why a lot of energy is needed to break it into a liquid and then finally into a gas. So the gas is the one where they have the weakest uh, forces in between them. The state symbols are pretty straightforward. S for solid, L for liquid, G for gas. Aqueous, you just write AQ, which basically just means dissolved in water. Okay, think of the word aqua. Now we're going to look at the properties. So going back to ionic compounds, they don't conduct electricity as a solid. Why? Because ions can't move and carry electrical charge. In your exam, you have to write carry electrical charge. Say they are not free to move, and as a result they can't carry electrical charge. Don't just say, oh, they don't conduct. No, you have to say they can't carry electrical charge. All right. Um, but when they are, so when it's a solid, it can't do it. But as a liquid, if we look back, remember how our liquid structure looked, they're more free, they actually can move. So they can move and they can carry electrical charge. Okay. They have a high melting and boiling point because of the strong electrostatic forces of attraction. All right. So if they ask you about melting and boiling point, you mention the electrostatic force. If they ask you about why they conduct, you need to talk about how free your ions are. Simple versus giant covalent. So we're looking at covalent now. So our giant covalent, diamond graphite, silicon dioxide is another one, but they all pretty much follow the kind of same thing. Giant has a high melting and boiling point. Okay, it's very hard to melt diamond and graphite. You need a lot of energy. The reason for that is strong covalent bonds. Please understand you only need to mention the intermolecular force in your simple covalent bonds. They can be at times where they do ask you for why the layers in graphite can slide past each other. Then you can mention intermolecular bonds, but you most definitely need to mention it in simple covalent bonds or simple covalent molecules. You have to say weak intermolecular forces. Giant covalent, do they conduct electricity? Yes, they do. Okay, or more specifically, not they, there's only one that does, and that is your graphite. Okay, so graphite is the one that can do it because it has delocalized electrons. Remember, you always need that freedom for your charges to move in order for electricity to be conducted. Okay, so electrons are free to move because um, graphite has delocalized electrons since it made only 3 covalent bonds. Okay. Summaries over here. Going at polymers, so the word poly meaning many. Okay, so polymers are large molecules. They're made from many single ones. The single ones are called monomers. Okay, so the monomers are kind of linked together, kind of like beads on a necklace. So loads of them come together to make one long piece. Okay, and they are strong covalent bonds. Their intermolecular forces are very strong, and they're all solid at room temperature. Okay, think of things like plastics. There are some exam questions on the side right now that you can use to help you. Please do give them a go. There should also be answers for each of these. So do skip over them. Not skip over them, but do give them a go. And that is it for bonding. Any other topic you'd like to go over, please do an exam paper. That's your best bet. practice it, and then you know, the specific questions you're stuck on, watch a YouTube video on it. Ask any of your teachers when you're free. You can come in, and that should be fine then. Graphene. What is graphene? Graphene is just a single layer of your graphite. So graphite is loads of layers. Graphene is like if I took one layer out, okay? And because it's so small and thin, that's what they use in like electronics. Fullerenes are like the hollow shaped, okay? Hollow meaning it's kind of empty on the inside. So if you look at the picture of this ball over here, right? It's called Buckminster fullerene. It's a C60, so there's about 60 different atoms there, and it's hollow, okay? And that has a spherical shape, so it's kind of like a football shape. All right. So then you need to actually no, we're gonna leave it there.